Hello, so today we are going to do this problem, which is part of today's Leetcode daily challenge, maximum length of repeated subarray. Yep, so the problem says we have two integer arrays, right? We have nums and nums1 and nums2, right? And what we want to do is return the max length of subarray that appears in both arrays, right? So sort of the intersection, but the maximum length between the two. So if you take a look at these two arrays, the maximum subarray is this one, which is equal in both, and so we return true. Here they are all zeros, and they have length of 5, and so we return that, right? So that's the idea here. Now let's see how we can solve it. Okay, so let's see how we can solve it. So the easiest way to think about this is, okay, well, what do we want to do? We know that if, let's say, you have a sequence like this, let's say you have a sequence that is equal. So maybe we traverse it here, and we are here. And by the way, like with this traversal, I'm thinking let's do a traversal on all the indices in, let's call this maybe in nums1, right? And then we do the same for maybe j. As an index for nums2, and we keep going as long as we didn't find numbers that are equal, right? So first, maybe we try and see like this, and we check if they are equal. They are not equal, so we proceed with j, and we continue proceeding with j until we find something equal, which is 1. 1 is equal, so we advance with 2 here. Right, and we try to find something equal to 2 after this, right? But we don't find it. And so the maximum length we found is 1. Okay, so we record that in our best. And then we do it again. We go, and this should work because it's of length 1000, right? And so we go again with I starting here, right? And j starting from all the way from the start. And we check 2 is equal to 3. No, so we advance j. Now it's equal. So we have 1, and then we advance. 1 is different. So when we find 2 is equal, we advance j and we advance I, right? And now 3 is not equal to 1, so we advance I and we keep advancing. We don't find 3. So now the length is also 1, so the best is still 1. And we keep doing this, right? So this should work, right? Because once we get to 3, right, we will start here for j. And it's equal, so our current count is 1. And then we advance. And 2 is equal, right? So now it's 2. We advance, 1 is equal. So now it's 3. Okay? And so you can see now the best is 3. So this should work. Now the problem becomes, okay, how do we implement it? Well, the easiest way is to do some sort of like, you can think of it as dynamic programming, where we have a DP of I and j, and this you can think of it just as a place to hold the max length of repeated subarray, so the intersection in both that ends in, just like we did here, like when we did this, that it ends at position for nums1 and it ends at a position for nums2. So that ends at I in nums1 and j in nums2, right? And if we do this, it should be easy. We can just check if the number at position I is equal to the number at position j. That means that this here is going to be just 1 because we just found an equal 2 elements, so the length just increased by 1, plus whatever we found, whatever was the max for the previous state, which is I minus 1, j minus 1, right? Because let's say here, for example, when we were here, right? When we were at 3, and we found that 1 and 1 are equal here, we should just look at the state when we were at this position, the previous position for I and the previous position for j, and check what is the length there, and then add it here, right? Because every time we found two equal number, we advance both I and j. And so here we do dp of I minus 1, j minus 1. And that should be it. And as we go and we do the traversal, we just need to keep track of the best, which is every time we can take the max of the best and dp of ij. Okay, so now one thing to note here is that what about one problem we have here is that what about the first state? So dp 0 and 0 should actually be 1 if these are, it should be 1 if these are equal, right? But otherwise it should be 0. But that won't work here, actually. So what we can do is change our state a little bit to make the loop easier to write. So what we can do here is make this be dp of I and j be the maximum length of repeated subarray that ends just before, right before. So that ends at I minus 1 in nums 1 and at j minus 1 in nums 2. So what this would mean that this one here is the one that ends at I minus 2 and j minus 2, which means to find if we need to increase by 1, we need to check I minus 1 and j minus 1. And what this would mean is we don't need to do a special case for dp 0 and 0, because we will get here and it would be for dp of 0, 0. We'll check, so we'll check this. And we will do, so for dp of 0 and 0, it's 0, right? Because it ends at the position before 0, so that's nothing. What I meant here is dp of 1, 1. So that would be 1 if these two are equal. Otherwise, it's 0. And so in our case here, we will go here and we'll do 1 plus dp of 0, 0. Because it's 0, this will work and we'll get 1 if they are equal, right? But one thing we need to handle is we want this to be checked only if I is bigger than 0. Because we don't want this to be minus 1. Okay? I hope that was clear. Please leave a question down below if and I can answer if any of this wasn't. And then now here we need to return the best answer we found. So we need to keep track of that. We can definitely like go through, like maybe do row for row in dp, and for each row get the max and get the overall max, but that would be like another traversal over all the states, right? So that would be another expensive operation. So instead of doing that, we can just keep track of the best. Initially it's 0, right? Because the empty list, right? And then we can here at the end every time do best is equal to the max of best. Or actually just do it here when we update by 1, right? Because here it's not possible to increase, for it to increase, right? Because it's 0. And we do max of best and dp of I and j. And at the end we return best, right? Okay, so let's run this. Yeah, so we forgot to initialize dp array. So our dp array needs to be nums 1 plus 1. Why plus 1 here? Because for the last state dp of n plus 1, for the last state where the repeated subarray ends at n minus 1 and j minus 1, this would be dp of n1 and n2, n1 being the length of nums 1 and n2 being the length of nums 2. And so since we want this to be the last position to be n1, we need the range in Python to be length nums plus 1, so that the last position is length of nums plus 1, nums 1, yeah. And so now we do this, and this would be for length of nums 2. Actually, there are a lot of parentheses here, so let's just simplify this a little bit. So this would be the length of the first array, and this would be the length of the second array, and then we'd have here n1, and we have here n2 plus 1, and then we would use this. Yeah, so that's pretty much it. So let's run this, make sure it passes. Okay, so it looks like there is a slight problem here, so let's check. So the first thing we need to use n1 here, and then n2 here. Yeah, so the mistake here is that since we want dp of ij to be up to n1 and n2, and we want to check the last number be n, we need this to be, to look at the last position, we need to go to +1 here. So that n1 is the last position and n2 is the last position. And that should work, so let's submit. Okay, so with this solution, actually, sometimes we get time limited exceeded, sometimes it passes, so we need to see how we can optimize it. And with DP, this is good. First, doing a solution that is maybe, that is the full table, and then after that you will notice a pattern and see that you can optimize it. So one thing we can note here is that every time we take the previous column and the previous row, and those are the only thing we need, right? The previous column in the previous row. We don't take like the one before that. So every time we only need the previous row, right? We only need the previous row. So that what this means is that let's actually just keep track of two, the previous row and the current row. That way, we don't keep track of all of them because we don't need them, right? And so to do that, we would have one for the previous row and then another one for the previous. And why did I do N2 here? Because that's the columns, that's the J here. And so let's call this previous, okay? And what this would mean is that this here needs to be from previous. And this here will need to be dp of j because this is the current row. So let's actually make it current, call it current. And this would be current of j equal to 0. You could arguably say we don't need this, but we just leave it for clarity. We don't need it because we initialize to 0, but leave it. I'm going to leave it here for clarity's sake. And we still have dp of current j, right? However, we need to assign, so it's for each row. So when we are here, we want previous to be equal to current, right? So let's try this. So we want previous to be equal to current, but we also want this to be a copy. Yeah. So you might ask why a copy? Well, because otherwise we will reference the previous ones and update them. The previous row will still be referenced in prev, and we will override the values. But we want a copy so that we don't override it, right? And that's pretty much it. So you can see now it passes faster. Yeah, so that's pretty much it for this problem. First the like the full DP solution, and then we optimize it and that pass it. So please like and subscribe, and see you on the next one. Bye.